So just a quick explanation about valve seat cutting. So bear with me because this is a bit tricky to do, but I'll try and use my pen. So down here, this is the cast port, aluminium, and it's in the factory. They've done a little bit of cleaning up using a cutter just to blend it in. So then here, this dark bit, that is the cast iron valve seat, which is cast into the aluminium head during production. So they load up the die with all the unmachined cast iron valve seats, and then they inject in the molten aluminium to cast around it. So that's how they make them. So from this line here, so that's the aluminium casting, and then it meets the valve seat, and then the valve seat goes all the way to about there, about that line. So this is the seat, and there's a little bit of a radius just here on the seat. It's put in the factory. This is a 60-degree cut between that line and that line. Then we have a 45-degree cut between that line and that line. And then we have a 30-degree cut between that line and that line. So sorry if I got that wrong. 60 degrees, 45, 30, and then this is the radius tool that is used on the outside to unmask the valve. So he's got a radius cutter that just goes around, and obviously you can see it cuts into the spark plug, but that's not a problem. But that just unmasks the valve, and I'll show you that in a bit. So if we then look at a diagram, a little sketch I've just done. So here's the aluminium cast port. This here up to there, that is the cast iron valve seat, like so. And then this is the 60, this is the 45, then the 30, then the radius. So the radius is unconventional. Normally on most engines you don't do this, but this is just a tidying up thing, just to make sure that the gas flows nicely out of the valve on partial lift, just when it's opening, rather than full lift. So what this does is, first of all, he would have cut the 45-degree angle to get his 37.5 or thereabouts depth. Then to get the position of the 45 degree, because that's the sealing face, because the face on the valve is 45 degrees. To get the position and the width of that, you then use a 60-degree cutter and a 30-degree cutter to bring the width down and to position it height-wise. So on a valve, if this is the head of our valve, little radius there, and then a 45, then a little radius there. Ideally, you want that bit to be doing all the work. That's where you want your seat to be, up there, and you control that by doing this machining. I don't know how well he's done yet. He says he's lapped the valves in, but again, I'm a bit disappointed. You can see there's a bit of lapping done there, but the last thing before I put all these valves back in, I'm going to do a lap with really fine paste, so I know exactly how wide and the position of the seal is. So that's what we want on your valve. Basically, you want it up near the top, so that as soon as it opens, whoosh, gas goes out here. So that's the basis of it, basically. And yeah, basically what it does is allow gas to flow out. So if you'd imagine, if he hadn't put this radius cut in, it would go up something like that, the cylinder head, something like that. So actually when the valve opens, it's got to open a fair way to start letting gas out. So what he's done is done that radius like that, remove this shit. So as soon as that valve opens, whoosh, gas goes out of here. Exactly the same if it's the exhaust working backwards. On low lift, gas will still be getting in past the valve and be exiting the engine. So that's the basis of, well, that's a theory of what he's done. So I've now got my bare cylinder head, and it's time to start thinking about gas flowing.